Okay, here's how to do the two warm-up problems that are on the board. You were asked to complete the square for both of these problems. Now, they do look slightly different from one another, but the goal is the same. So let's look at number 1. In number 1, the goal in any problem where you're completing the square, to complete the square, you need your variables on one side of the equation and your numbers on the other side of the equation. So number 1 already sets itself up to where we have both of our variables on the left side and our numbers on the right side. So we don't actually need to move anything. So what I'm going to do is complete the square. So what this looks like essentially is you have x squared minus 8x, and you leave that blank and equals 11. That blank, if you remember from your practice, was the c value. And so your goal is to figure out that c value, and that's how you complete the square. The process for completing the square is to take half of your b, so half of this negative 8, and then square it. So half of negative 8 squared is this c. In this case, half of negative 8 is negative 4, and negative 4 squared is 16. So we add 16. Now, to keep in with the rules of equations, if we add something to one side of the equation, we do have to add that same amount to the other side of the equation. The goal when completing the square is to create a perfect trinomial on this one side here. A perfect trinomial will have the exact same number multiplied to be c and add to be b. So you have to think about what same number multiplies to be 16 and also adds to be negative 8. If you guessed negative 4, then you're correct. So what this ultimately looks like is if we were to factor this, what multiplies to be 16 and add to be negative 8 is negative 4 and negative 4. If we were to factor this, ultimately it would look like this. You do your dead cartoon eyes, and you have x minus 4 and x minus 4. And on the right side, 11 and 16 is 27. But we don't have to write x minus 4 times x minus 4 because anything multiplied times itself is just squared. So we can just write it as x minus 4 squared. So write it as x minus 4 squared equals 27. And then the final step is to then take the number that is on this side and move it back over here. So what you ultimately end up with is x minus 4 quantity squared minus 27 equals 0. And that is called completing the square. Now you could solve it completing the square, but we're not actually going to solve these by completing the square. We're just going to get the practice in doing the process of completing the square, because that's what you're going to use today when you do circles, and next class when we do transformations of quadratics into vertex form. Because ultimately this is vertex form, and because the numbers that are here represent the actual vertex. The vertex would be 4 and then negative 27. Okay, let's look at number 2. Now, number 2 is not set up quite as easy as number 1, in that you don't have the separation of your numbers and your variables. So the first step that I need to do actually is to move this negative 5 over here. So I get x squared plus 10x, leave my blank for that c value, equals 5. Now I have to complete the square. Completing the square is taking half of your b and squaring it. Well, half of 10 is 5, and 5 squared is 25. So plus 25. And what I do to one side, I do have to add to the other side. Okay, this turns into a perfect square trinomial in which what number multiplies to be 25 and then what that same number has to add to be 10. So if you guessed 5 and 5, then you're right, but we don't need to write 5 and 5. We just write x plus 5 squared equals, and 5 and 25 is 30. Final step is to move 30 back over here, so you get x plus 5 squared minus 30 equals 0. And that is completing the square. You will use this technique today when you're learning about circles, as you have to complete the square in order to do circles. You'll also use it later on in this third unit here when we switch up quadratics into vertex form. So, hope this helps, and have a good day.